Apparatus description. Introduction. Gas turbine plants are widely used in generating mechanical and electrical energy by driving electricity generators in power stations, driving compressors and pumps in oil and gas production, driving ships and heavy vehicles, and are also used for the propulsion of aircraft with propeller and jet engines. Gas turbines are always used if high power density, low weight, and quick starting are required. Contrary to piston engines, the gas turbines permit high material flow rates in small dimensions. In this way, light, and at the same time, powerful drives can be produced. As the moving parts of a gas turbine only perform rotary motion, almost vibration-free running can be achieved if the turbine is well balanced. Disadvantages of using the gas turbines are the high gas speeds and high noise emissions due to the simultaneous connection to the atmosphere. In comparison to steam turbines, gas turbines work at higher temperatures but with lower pressures. The high temperatures, particularly in the area of the turbine, require particularly heat-resistant materials. The testing apparatus used in this experiment is a two-shaft system with radial compressors and turbines. The power turbine drives an electrical power generator. All components necessary for the operation of the system are combined in a compact arrangement. The control and display of all important process parameters is combined on a control panel. A clearly laid out process schema on the control panel eases the allocation of the measured values and assists in the performance of the experiment. Apart from the pure demonstration of the operating behavior, it is also possible to perform qualitative investigations, such as the determination of the electrical power output, the specific gas consumption, or the system efficiency. Operation with propane gas ensures clean, odorless operation and good exhaust gas quality. This apparatus is a demonstration unit that contains a complete gas turbine system with the following subsystems: a gas generator consisting of a compressor, a turbine, a combustion chamber, and an intake system with a muffler. A power turbine with an exhaust muffler and a belt drive to the generator. A generator. A starter system with a starting fan and a changeover damper. A fuel system consisting of a main valve, a rapid action stop valve, a pressure regulator, a control valve, and a burner nozzle. An ignition system with ignition plug and ignition transformer. Measuring instruments and controls with temperature, flow rate, speed, and pressure measuring points and associated displays. These also include the safety components such as temperature and pressure limiters, oil pressure, and oil temperature monitoring. All system components are arranged in a steel frame. The frame is closed towards the front by the front panel. The front panel controls and displays are numbered to ease the data collection. These numbers correspond to the numbers on the worksheet. A two-shaft plant has two independent turbines. The first turbine only drives the compressor. As the entire pressure drop available is not needed for this process, there is enough energy for a second turbine connected in series. This second turbine, also called the power turbine, generates the useful power. The advantage of this arrangement is that a change in the load or the speed of the power turbine has little or no effect on the compressor. This continues to run at the optimal speed in the best efficiency region. Even the jamming of the power turbine cannot cause damage to the plant. For this reason, the two-shaft plant is preferred for vehicle and ship drives with widely varying load requirements. In addition, the speed of the drive can be better matched. As the first turbine, together with the compressor and the combustion chamber, only generates the working gas for the power turbine, this group of components is also called the gas generator. This consists of a radial turbine with a directly coupled radial compressor and combustion chamber. The turbine and the compressor, together with the bearing housing in between, form an air compact unit. This unit is normally used as a turbocharger on turbocharged engines. The air drawn in is injected into the light alloy spiral housing by the compressor wheel rotating at high speed between 60,000 and 125,000 revolutions per minute. The speed of the air is converted into pressure. The compressed air is further slowed down in the diffuser and then fed to the combustion chamber. At the inlet to the combustion chamber, part of the air is drawn off and fed to the front of the combustion chamber pipe. This primary air is used as combustion air for the fuel. A turbulence generator sets the air in rotation and slows it down such that the fuel is injected in gaseous form via the combustion nozzle and can burn with a stable flame. The combustion pipe is cooled from outside by the secondary air. This is fed to the combustion chamber via holes to cool the very hot combustion gases, approximately 2,000 degrees Celsius, to the permitted turbine inlet temperature of 600 to 800 degrees Celsius. An ignition plug is used to ignite the air-fuel mixture on starting. From the combustion chamber, the combustion gases flow into the spiral housing on the turbine and are accelerated for entry into the radial wheel.